Okay, now this session we're going to talk about making a mold. I'm going to take this one here as a typical. Two processes. Again, I'm using 3 laminations of 3/4 plywood simply because these frames are 2 inches and we want a little bit of wiggle room when we're doing with the clamps. Now, because we have 3 layers, we're not going to mark and drill holes. We're going to try to transpose this pattern onto this plywood so that we can cut it and have some symmetry. Now, in this particular case, we're going to half this up. And these plywood pieces are cut to be just a tad wider than this particular pattern. But the most critical component is the center line. Now, the easy way to do this is to check my transition marks on my mold, the end center, the middle, and the tail center, like here. So all I'm going to do right now is match this line and this one with the center line I have on the plywood. So we have that lined up. Now, all I have to do, because I have an existing mold, is to trace this out on the plywood, on this half. Now, in order to guarantee a certain degree of symmetry with the frame itself, this one might have been damaged over the years. It has a little gouge here. I know this half is on here. All I'm going to do is use the same edge, redo the center lines, and then we're going to mark out this one. So if we remove this, that would be our pattern. Now, the other thing that we need to do is we need to have some key placements for the clamping to hold those frames on here when they're steamed. Now, the most important one is the middle. On the top, the middle on the bottom, and then the areas where the frames will end. So the bottom frame is going to end where this cross beam location is indicated. So it's right around here. So we've got to have a hole to catch that end, to keep it in there and true to the mold when we're steaming. Similarly, where the bottom beam is located here, we're going to need, this would be a keyhole here. So I'm just going to mark those with the pencil. And give me a center point. That gives me an indication of where I need those critical holes. But you still need all of these because of the birch. It can be contrary with you. It's a little bit of twisted. You might need more clamps to keep it in true. Especially if it's a pliable wood. So we're going to take that away. And what we'll do is we're going to put this one aside. And we're going to take another example of how do I make a mold if I don't have a mold to go by. We're going to put another center line on this other piece. So we've got a center line. Now, what kind of snowshoe do you want to have? We march that center line, this center line. What you would do is bristle board, cardboard, anything that you can cut fairly easily. You could freehand a snowshoe. So let's take something a little bit different than that. A little narrower. Get a nice radius up here. And this is not by any stretch of the imagination rocket science. All I'm trying to impress on you is you can make the pattern to whatever you want it to look like. The key here is this center line. You don't draw the whole snowshoe. So what you would do now is we'll join this straight line on the bristle board or cardboard. And we would cut this cardboard along that line till you're satisfied with how wide it is, how long it is, what your turning radius is. We would cut this out, and we'd do the same thing with the mold. So in this particular case, I'm going to cut this straight line only right now. Oops. Now with my trusty scissors, we're going to see what kind of creation we've got here. Okay, we've got half a mold. Now, all we have to do is transpose this line, if you're satisfied with it. And similar to how we did it with the actual mold we were using as a template, we'll just flip this over. And you can't pin it, but this is pretty good. And we have another pattern. That's all there is to it for that. Now in the next session, what I will do is I'll go to the layout of the cross beams and the locations for the holes, and then just use the compass in order to lay it out so that we can have, first of all, the keyholes in the right places, and then we can do some similar ones around that are far enough apart that they're not going to weaken the frame, and at least enough to be able to take in any wrinkles we'll get in the steamed wood. Okay, now that we've got this first frame layer cut out on the either jigsaw, bandsaw, whatever you choose, what we have to do is identify what the distance is in for the holes. Now on the previous mold, I think we were in about 1.5 inches for the center line. So I'm going to set up my square for 1.5 inches center line. Now we're going to scribe the perimeter to get a line so that all the holes will be back in about the same area. Now in this particular case here, when we did the initial layout, we marked some key spots. That's where the lap is going to be. That's where the top is going to be. Subsequently the other lap. and the end one. Now, we'll set this up. And what we're going to do is we're going to run a parallel line around the frame. What this line is going to do, it just gives us the distance for the center line of the holes that we're going to put in the finished mold for the clamping purposes. So now, we know these are our key spots, but if we look at the mold, there's a lot more holes in there. So what we're going to try to do is put some, in this particular case on the previous mold, these are approximately, I don't know, 2.5, 3 inches maybe. Let's check it out. Yeah, they're about 2.5 inches apart. Rough order of magnitude. So all I'm going to do for the top part is I'm going to take my compass, set it up at about 2.5, and see what kind of spacing we get for the center lines of our holes. So that's pretty good. And we need another one in here. The transition on the bends is where you get all the force, and as you clamp to this particular area, you always need to be able to hold that in so that stops the beams from flying off when you're trying to steam them. And we'll do the same thing on this side. And I think I might even squeeze another one down here. That's a big pressure point. So we'll just half that up. Now that we've got one component of our frame, one thickness, for the ease of assembly, that one's a little bit off there. For the ease of assembly, what I would do is I would drill the holes in this particular layer first before I start assembling them. And why you want to do that is because we're going to screw these together from both sides. We'll just screw this one on here with probably 1.25 inch screws, and then we'll drill these holes down just till we get into the thickness of that one. Then we can put 3 together. Some people like to cut this one layer at a time. If you have a jigsaw, 2 layers of 3/4 with this without damaging your mold is going to be more difficult. Where I'm using the bandsaw, 2 is not an issue. So what we would do is we would have these screwed together with the first holes drilled, then assemble all 3 layers of the plywood, and with the aid of a Forstner bit, we start to cut these holes through. This is a D grade plywood. It's fairly soft, so you don't want to force the bit, and it doesn't self-clean, so keep penetrating, drilling, penetrating. But your bottom surface should be scrap wood, so that when it finally breaks through, it doesn't splinter away the hole, and you get a nice clean cut like these over here. Okay, now that we've got this basically marked out, we're going to cut a couple of the holes just to give you an idea. Here's my waste wood underneath. It's going to enable me to get a good clean cut, supposedly. Check that out. So, this is our penetrating side. So we got a nice clean hole. It hasn't splintered away. So what we do is we proceed to drill all those holes, and then we'd assemble this to our first board. And again, it depends on what tools you're using to do your final cutting. For me, I would do all 3 assemblies, and then the bandsaw can easily cut those thicknesses. Now, the trick here is the first few screws, you have to put them in the mold away from any areas you're going to be drilling. You can reinforce the edges a little bit later so that we're not going to get a hole. So I'm probably going to put 4 screws just to hold these layers together. Make sure we got all our ends. Now that we've got this together, we can proceed with drilling all the holes through all 3 layers, saw it out, and then resecure the 3rd sheet just for a little double penetration through to the middle one, but you don't necessarily have to introduce it to this one. So you don't need great big long screws that are 2 1/4 inches long. 2-inch screws would be good. You don't want anything protruding through because it would be dangerous to your hands. Once these holes are all cut out, then we will take this and try to establish where the beams would go. Now that we've got the mold template cut out, we're going to try to find out the positioning for our cross beams. Now, symmetry is critical here. So the first thing we need is our center line, which is on our template. And in this particular case, I'm going to just take it from this mold because I'm trying to replicate it where this one's starting to be damaged. And what I'm going to do is I'm going to find the distance from the top of the cross beam here to the center line. That's 9.5 inches. So in this particular side over here, this one should be 9.5 inches. So what we have to do is 19 inches is the top of our cross beam. So I'm going to go from this center line, 9.5 inches, and do the same thing on the other side. So I've got to mark where the top of the beam should be. Now for this transition, I'm going to use actual beam template. I'm going to put it on here. Now right now these marks are in pencil. I will make them with ink or permanent marker so that it doesn't wear away so fast. These get a lot of use. So that's the position of our top beam. Now similarly, we'll turn this all around. And we're going to turn around the mold. And again, we're going to go from our center line to the top component of the beam. And that's 5 3/4. So a 5 3/4, and we mark the little top. We'll do another 5 3/4 for the other side. We'll take our beam template. So all of our important lines are transposed on here. These will be used after the frames are seasoned and you disassemble in order to mark them before you nail them, so you don't put nails where you're going to have to mortise out the wood that we previously covered off. And that would be your frame. If you didn't like where these were and you don't have a mold, make a template. It doesn't have to be arced, it can be square. Position it somewhere along these lines, but make sure it's equidistant from the center line for the top beam, down somewhere on that side, wherever you decide to put it, same dimension for the other side. Similarly down here, if you want the tail section to be a little bit bigger, pick a mark, trace your line across, make this side here the same distance, and you've got your beam locations. It's not rocket science. It doesn't have to be here or here or here. It's wherever you decide you want to put it. The next stage we'll have this completely drilled and screwed together, and it's ready for birch. Now that we've got the mold finished, as in all 3 sections cut out, we've got all the Forster bit holes put in where we made the parallel line around, and the key ones we've got where the beams end, here and here. So now if we were to simulate a birch slat that's going to go around here, we need to know how long do we cut each piece before we stick them in the steamer, because when they come out of that, they're going to be 200 degrees plus. We can't mess with them to make sure they're going to fit the mold. So what we're going to mark on here is we're going to figure out what's the length we require for the bottom slats for the snowshoe and the top slat. And then we're going to mark it on here, so as you can see with multiple molds on the go, we don't have to measure this up every time. In this particular case, we're going to measure up for the bottom one first. So the bottom slat of a snowshoe, ideally, is going to end here, where this cross beam will be placed. That would give extra support for the beam, including the mortise. So it has more support in that it won't wear down through or slip out. Now what we're going to do is we're going to take a tape measure and we're going to run from this point all the way around to this point over here. That's going to give us the dimension for our bottom beam or slat. So we're going to take our dandy little tape, run it around the outside dimensioning, and right there it says this one should be 44 inches. But the 44 inches is the exact dimensioning of the mold in itself. So if you imagine that we've got a slat of wood that's 3/4 of an inch thick, that's going to run all the way around here. That outside dimension is going to be considerably more. Number one, it's going to be at least the 3/4 here that's going to add to the width and the running length. Plus there's going to be some more for the wider component and the arc that it creates. So what I've found with respect to most of these molds is when we get this dimension here, we need 2 inches more for the slat by the time it's bent, and we compensate for the outside dimensions of that whole strip. When it gets up to here, it's going to be basically tapered down to nothing. But the continuation of that 3/4 piece all the way here necessitates that what we measured to be 44 is the true dimension of here. But in order to have our slats long enough that we'd be able to come up here to the bottom of the beam, we're going to add on 2 inches. So the bottom slat is going to be 46 inches. Now, similarly, we're going to measure the top. Again, the bottom beam went from this beam intersection, cross beam, around and up. Now, for the top slat, we want to come at least to the start point of the bottom cross beam. So again, we're going to take our measurement from this point. We're going to come all the way around again. And right here, we've got 52 inches. Now, it's not as critical here with this 52 because this tail of the slat for the top of the snowshoe can run anywhere from here to here. It's just that we want to have something that's consistent. So if we wanted them every time to finish back down here, the same thing would have to be considered in the compensation for the thickness of the beam and, the slat, the thickness, and the increased outside dimension it makes by coming around. Now, with 52, I would leave this one here for now, and then I'd look at it and say, okay, do I want to interfere with the mortising? Because where this beam goes in, we can't have nails, so we don't want the strip to finish up down here. Here would be the max. Anywhere back here would be okay. So that's maybe 3/4 of an inch length. So in this particular case here, even though we had 52 all around there, I don't want to impose on this particular section of the lower beam for the mortising. So I'm probably going to leave this one at 52 because 2 reasons for that. This 52 is going to relate to the maximum length of the tree that you got to cut down. You start adding on inches, you add on significant pounds. Normally, I will rough saw a tree to 54 inches, so I've got wiggle room in case I get splits. And the other limitation I have is with respect to the steamer. The steamer is maximum 56 inches. So the 52 gives me a good safeguard that I'm going to get somewhere around here, even to this hole. And this will be the most important one for putting on the top strip, because this clamp would be able to be applied exactly over the end of the slat somewhere here. And likewise, the end of this one, this hole is going to pick it up. So we know we're going to get good contour, but we're going to get good clamping abilities here and not interfered. So we've got the top and the bottom. Now, the other component that we have to measure is both of these beams, when they're originally cut, have to have a taper. We can't have two great big square boxes up here joining each other. So the taper enables me to have a continuous cross-sectional thickness of the snowshoe frame, considering we're joining two woods. Now here, we don't want the taper to start down here because we need the maximum width of a beam to get at least a half cross-section mortise for the insertion of these, because these are all just friction fit. So we want the full thickness of our beam here. That's 3/4. The same thing up here, which is even more important because that's where most of the weight will be. So we want full 3/4 here. So somewhere between here and here, we need to create the taper so the full cross section of that, both of those joins, is still only 3/4 of an inch. Now, we don't want to flirt with this, and we don't want to flirt with this. So again, it's choice to a certain degree, as long as you don't make the taper too long. If we made the taper too long, if we started the taper down here somewhere, and we went up, let's say that's 16 inches. What we're going to do is we're going to have too small a cross-section area of the wood here to create the mortise, and too small here. If we come in here, we're still flirting on the edge of it. So we're going to try to get a compromise in the middle. In this particular case, I'm 1.5 inches in from the bottom beam, and I'm 1.5 inches back from the top beam. That means I'm left with 12 inches. That 12-inch is what I'm going to create my taper in. So the 12-inch taper will be consistent on both slats. And then we will still maintain the same cross-sectional thickness of the snowshoe all the way up around, but we'll be able to have a nice join. And we just finished a gluing session that the wood is not going to be bulked out, but then it's not going to be really thin. Because if it was too thin here, when you're doing the fillings, you're going to cause it to want to collapse a little bit. So the taper we're going to run with is 12 inches. And it will be consistent with all ends of the top and bottom slats. So here, basically we have a finished mold. We've got our center line, which is very important. As we noted when we marked out our slats to prepare them for steaming. We've got our taper dimension for the sides and the ends of the beams. And we've got the top beam. So this next step for this one will be cut some slats, smack them in the steam, and get them on here. The one thing you want to watch for in here is any spalling or weak spots in the wood, because the clamps will want to compress that. Other than that, this one's ready to go.